Yes, de Moivre's theorem, another little stroke of genius. If we take the cosine of x plus I times sine x and raise the whole thing to the power of n, then the theorem says that this equals the cosine of n times x plus I times sine of n times x. And that's much simpler than if you think about it. If n is already 2 and you had to multiply it out, you would need the binomial identities. To the power of 3, 4, 5, that's not even worth mentioning. And that, of course, makes the calculations much easier. I also have example problems in the playlist on complex numbers. The derivation for that would require us to go back to Euler's formula. If we take cosine of x plus I times sine of x, that's equal to e to the power of I times x, right? Which again simplifies the calculation when we have the wonderful base e. And if we now go ahead and say, okay, we raise this to the power of n, then of course we do the same here, and then we apply the third exponent rule. I to the power of I times x to the power of n is equal to. Powers are raised by multiplying the exponents. It's much simpler here. And that's it to the power of I times and times x, which when multiplied out would again be cosine of nx plus I times sine of nx. That's the fascination again when you combine things in mathematics. Be sure to check out the playlist on complex numbers too, where you'll find everything else along with plenty of practice videos.